Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So in my previous videos, I was actually discussing about the gravitation chapter, which was the 9th chapter of 9th standard science subject. So in this particular video, I will start the new chapter, that is the 10th chapter of 9th standard science subject, that is on work and energy. So now, before seeing what you mean by energy, first let us try to understand work in this particular chapter. So what do you mean by work? So in day-to-day life, we generally use this term called work because everybody works hard for their life. So whatever the hard work you put physically or mentally, we generally tell that as work. But in science, that is not work. For example, if a student studies hard for exams, for example, if a student studies hard for exam, then we say that this particular student is working hard. So that means this particular student is working hard for his exams and to get good marks. But here, this kind of hard work is not considered as work in science. Even if a person who is trying to push a big rock, so let's say there is a big rock kept on a particular land. So now a person stands beside this particular big rock and he tries to push this particular rock. So when he tries to push this particular rock, that rock doesn't move at all. So that means here person will get exhausted because he is spending his energy in pushing rock. So person gets tired, but rock doesn't displaces. So in general, we claim that this person has done the work. But actually in science, especially in physics, he has not done any work. So in physics, work done is different. So here, he has not done any work. Why he has not done any work? We will be learning that in this particular video. Similarly, if another person stands on a surface and if he lifts a particular object for a longer time like this, after a while this person gets tired because the weight which he is carrying on his hands will make him tired. But here there is no displacement of that particular object. So here also, in general, we claim that person might have worked, so that's why he is getting tired. No, person has not worked according to physics. Here also, when this particular person tries to push this rock doesn't move at all. So this rock doesn't move. So there is no movement of this rock. So this rock is not displaced from its initial position. So that means here, even though person has spent energy, even though the person has got tired, even though the person in general, he has done some work, but according to physics, according to science, he has not done any work. Work done is zero. So here also work is zero and here also work is zero. Because here, whenever you claim that some person or some object is doing some work, then the force and the displacement comes into picture always. So for example, if a particular table is there and on this table a book is there like this, and there will be a person who is standing next to the table and this person pushes this particular book. That means he is applying certain amount of force on this book, and this book he will move to this particular position. So that means book has moved this much amount of distance. So that means from its initial position, book has got displaced, and how much amount of force and displacement both should be there. In previous case, what was happening is that here also this particular person was applying force F on this particular rock. But as you all know, in gravitation chapter we have learned that when mass of a particular object is higher, then weight will also be very much more, because weight is nothing but mass times acceleration due to gravity. So that means greater massed object will have more weight, and because of more weight there will be more static friction developed in between this rock and land. Because of that static friction, that rock needs more and more force to displace that rock from its initial position. But this person is not putting that much amount of force to displace this rock. Here person is applying force, but he is not putting enough amount of force in order to move that rock from its initial position. So that means here there is no displacement happening. So rock is not traveling through a certain distance along the direction of force. So that's why even though force is applied by this person, there is no work done at all, because there is no displacement of this particular object. Here also, when a person carries an object and stands like this, so he is stationary. The object is stationary. So that means there is no movement at all. There is no displacement. So that's why here also, even though the person is carrying the object, that means he is putting necessary amount of force opposite to the gravitational force in order to hold that particular object, but still work is not done because there is no displacement happening. So here also work done is 0. But for example, this person lifts the object from the ground, then that is work, because the object initially it will be on the ground, and when a person lifts that object, for example, if I have this phone on my hand and if I am lifting this particular phone, that means this phone is getting displaced from its initial position and I am applying certain amount of force as well. So that means here while lifting this object I am doing work, but while holding the object like this I am not doing any work. Even though I am putting force on my fingers to hold this particular mobile phone, still there is no displacement of this phone, hence work done is 0. But while lifting this phone from the bottom surface, from my hand, from my other hand, I am doing some amount of displacement by applying certain amount of force for this phone. So that's why there I am doing some work. But even though in another case where I am putting force but I am not displacing any object, like for example phone, so that means work done is 0. So here also in this case work done is 0, here also in this case work done is 0. But in this case the person is pushing this particular book which is kept on the table, and it is covering certain amount of distance and it is getting displaced from its initial position to another final position. So that means here work has been done. So always remember, for work, so when you talk about work in physics, you should remember 2 points. So one is force applied. So first thing which you should consider is force applied and the displacement of a particular object from its initial position. So now we have scientifically understood what do you mean by work done. So now let us try to mathematically understand what is work done. So now we should try to develop a particular formula. So whenever you are claiming that work has been done, then what comes into picture? So in work done, what are the two terms we get? The two terms which we get is the force and the displacement of an object from its initial position. So now work done depends on both force and displacement. So that means here product of force and displacement will give you work done. So product of force and displacement give you the work done. So that means how much amount of force you put, that much amount of displacement can happen and work can be increased. So that means here work done is directly proportional to force, and also work done is directly proportional to the displacement done by that particular object. So that means here mathematically work done, so work done we can call this as capital W will be equal to F into S. So F is the force applied and S is the displacement along the direction of force. So that is work done. So now we got the formula for work done, that is W is equal to F into S. So now we should try to find out what is the SI unit of this particular work done. So what might be the SI unit for this particular work done? Here we have force and displacement. So the SI unit of force is Newton and the SI unit of displacement is meter. So Newton meter can also be known as joule. So Joule, either you should write small j and expand the full form, or you should write capital J and you should not expand the full form. You should just write capital J, or you should, if you are writing the entire SI unit, then you should keep this first letter small. So even in my previous chapter I told for force you can use Newton as the SI unit, so N should be small, and if you are not expanding the entire SI unit, then you should keep only capital N. Similarly for work done also you can use joule. So here if you are writing the expansion of joule, then you should use small j, and if you are not expanding joule, then you should just write capital J. So joule is the SI unit for work done, or Newton meter is the SI unit for work done. So now what do you mean by 1 joule of work? So now we will just try to understand what do you mean by 1 joule of work. So 1 joule of work is the work done by 1 Newton force to displace an object by 1 meter. So what do you mean by 1 joule of work? 1 joule of work is the work done by 1 Newton force to displace an object by 1 meter. So because in work done, W is equal to force into displacement. So now if force is equal to 1 Newton, then F is 1 Newton and displacement is 1 meter, then in the place of S I can write 1 meter. So 1 Newton into 1 meter, that is 1 into 1 is 1. So work done is 1 Newton meter, or you can claim this as 1 joule. So that means 1 joule of work means it is the work done by 1 Newton force in order to displace an object by 1 meter. So if an object is displaced by 1 meter just by putting 1 Newton force, then the work done is 1 joule. So this is the definition of 1 joule of work, or simply it is the definition of joule. So the definition of joule or 1 joule of work is the work done by 1 Newton force to displace an object by 1 meter. So now coming back to the example, so there was a big rock lying on a ground like this, and a person was trying to push this particular rock like this. But this rock was not getting displaced. It was staying where it was staying. But still this particular person was applying force on this particular rock. So that means here person is putting certain amount of force, so that's why F is not equal to 0. But displacement is 0 because rock is not moving from its initial position at all. So that means here displacement is 0, hence the work done will be equal to F into displacement. So F is non-zero but S is 0, so that's why the entire equation becomes 0. So that means work done is 0. So that's why even though this particular person is putting force, even though this particular person is exhausting his energy, still the work is not done. So that means here if you ask science if this particular person has done some work or not, the answer is 0 because work is not done. But he has put some force but work is not done because displacement is 0. So here you have one example. So in this particular chapter, if you focus on example 10.1, here they have given a force 5 Newton is acting on an object. So that means here they have given force as 5 Newton, and they have also claimed that this particular 5 Newton force is applied on the object, and this particular object is displaced by 2 meters. So that means they have given displacement also, that is equal to 2 meter. So now force is 5 Newton, S is 2 meter. Now you have to calculate the work done. And one more thing is, this displacement has happened along the direction of force. So this displacement has happened along the direction of force, because whenever the displacement happen along the direction of force, then the work done is always positive. So whenever the displacement happens opposite to the force, then the work done is negative. So I'll just explain that. Before that we'll complete this example. So now work done is 5 Newton into 2 meter. So 5 into 2 is 10 Newton meter, or 10 joule is the amount of work done by this particular force on this particular object. So now I was explaining along the direction of force. So whenever the displacement, so always remember displacement happening along the, so now we are only discussing about displacement. So displacement which is happening along the direction of force. So if this displacement is happening along the direction of force, then work done is positive. So work done will be positive. And if displacement is happening, so now the same displacement, if it is happening against the direction, so against the or opposite to the direction of force. So if the displacement is happening opposite to the direction of force, then work done is negative. So that means here work done is negative. So always remember, work done is negative when the displacement happens against the direction of force or opposite to the force, and whenever the work done, the displacement is happening along the direction of force, then work done will be positive. So now, for example, if a particular person who is standing on a surface and if an object is lying on the ground, if this person puts some force in order to lift this particular object, and object is lifted to this particular height. So when this object is lifted to this particular height from its initial position, that means there is certain amount of displacement is happening, and this person is also putting some amount of force. So that means the force is applied in this direction and displacement is also happening in this direction. So that means here work done is positive. So now if we try to understand what is there in example 10.2, here a porter lifts a luggage from ground. So there is a luggage on ground and a porter is standing, and this particular porter lifts this particular luggage from ground. So the data which they have given here is the mass of this particular luggage is 15 kg. So this is the mass of the luggage which is kept on the ground, that is 15 kg, and he has lifted 1.5 meter above the ground. So he has lifted 1.5 meter above the ground. So that means here they have given the displacement, that is 1.5 meter, and they have given mass, that is 15 kg. Now you have to calculate the work done. So what is work done? Work done is force into displacement. Here you can consider this as mass times acceleration due to gravity, because here he is putting the force against the gravitational force. That means he is lifting that particular object from the ground surface against the gravity. So that's why here the acceleration which is involved in this force is acceleration due to gravity times mass times displacement. So work done W is equal to, what is the mass? Mass is 15 kg into acceleration due to gravity is 9.8 into distance is 1.5 meter. So now if you calculate this, W is equal to 22.5 into 9.8. So that means here I am just multiplying 15 into 1.5. 15 into 15 is 225. Here one decimal point is there, so I am putting that decimal point after 5. So 22.5 into 9.8. So now if you calculate this, you will get the work done. 220.5 Newton meter or 220.5 joule is the work done by this particular person. In the textbook, they have used acceleration due to gravity as 10 meter per second square, but here in the question they have not mentioned you should use acceleration due to gravity as 10 meter per second square. So that's why in that cases you should always use 9.8 meter per second square only. So that means here in textbook they have used 10, but whenever you are solving any kind of problem, unless and until if they mention use acceleration due to gravity as 10 meter per second square in the question, don't use acceleration due to gravity as 10 meter per second square. Only in the question if they mention 10 meter per second square, take acceleration due to gravity as 10 meter per second square, then only you should take acceleration due to gravity as 10 meter per second square. If they have not mentioned anything in the question, then straight away you should take acceleration due to gravity as 9.8 meter per second square. This was all about work. In this particular video, I have covered most of the things which is there in this particular chapter related to work. So in my next videos, I will be discussing about energy which is there in this particular chapter. So till then, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.